All right, well, with that, I'm going to throw it over to Matt, and he's going to dive into lighting design theory. You ready, Matt?
Yeah, let's do it. I'm kind of gonna close up some just to get it as dark as I can in here.
Do it. Start with you.
Cool. So yeah, we're gonna talk lighting design theory, and we're since we only have an hour. I mean, design theory is pretty dense, for lack of a better term. So I kind of wanted to dive into just kind of one aspect of it, and I think it's a piece that we're always concerned with the stage and what's behind your subject, what's behind your worship team. But we don't really ever kind of drill down on like front lighting. So yeah, we're talking lighting theory and design theory, but we're really going to be drilling down into um, front lighting and how to use that both effectively as far as like lighting for video, lighting for to make it look even and everything look nice and bright and good, but also using it to evoke emotion or to help sculpt um, your subject in whatever environment that is and in whatever capacity that is or whatever element you're doing. So I've got I had like some examples and I had a slideshow, but figured I would just set up a lighting rig and I'm in one of our spare bedrooms, so I have just so you kind of get a gear list of what I'm working with is I've got three Elation 6 par 300s. They've got a white, amber, or they're RGBAWs, so they have white and amber, which makes them kind of great for this illustration. And I've got them in as close to a 3 point lighting system as I can, as far as having two side lights, a center light, and then I also have on the floor here like a true side light to kind of give some kind of real life examples. So, but anyway, we're gonna sort of before we kind of dive into examples and things like that, we're gonna get some language sort of sorted out. So if you've been around lighting for any length of time, you've probably heard front light, band wash, special, key light, worship light, sermon light, and a lot of those get used very interchangeably. So I wanted to, before we just sort of go into examples, kind of dial in what those all actually mean and maybe set some things straight a little bit. So the first question is key light. What is it? What is key light? And in kind of a nutshell, key light is the brightest source hitting your subject. Some people will use front light or any light hitting your subject as key light, and it actually boils down to it being the brightest source. So just a quick example of that. I'm going to brighten this up a little bit. So an example of a key light would be, so I've got this side light. That would be considered my key light. I'll also add, I've got this other light over here. I'll just turn it down. That would not be my key light. That kind of brings me to my next one. That would be our fill light. So some of these terms, if you spend time shooting videos or things like that, you might hear the term kicker or like just a smaller, basically a smaller light that just sort of fills in shadows that the key light kind of creates. So if we were to take away this fill light, you can kind of see on the right side of my face, it's pretty dark, and versus the left side. So we would add in some fill light. So it can be the same source, just turned down, but it's the fill light is a lower intensity than your key light. So then we also have, so we kind of nailed like talked about front light, side light, band wash, foot light, hair light, or backlight. Those are basically in reference to the location. So instead of basically saying, "Oh, turn on the key light," well, you have to specify which light you want to be the key light. So, for example, so if I'm saying, "Hey, I want my front wash to be my key light, I would say I want my front key. So that would be in relation to this is the front light. And then if you said, hey, and then I want to add like a side fill, you would add in that side fill light. So yeah, so that's sort of kind of the language of just kind of getting that sort of established as far as when we talk about key light, when we talk about fill light, and then front light, back light, things like that. That's in terms to relation. So hopefully that all sort of makes sense to y'all. I'm a bit of a history buff. So one of the things that I kind of run into is everyone, not everyone, but most lighting professionals, you'll hear the term 45-degree angle. I need a 45-degree angle on my front light. And one of the things is like, where does that come from? Who established 45-degree angles as I guess the preferred angle for front light? And there is actually a man by the name of Stanley McCandless. So if you've ever been around and studied lighting theory or lighting design, you've probably heard his name. He was born in the late 1800s. Lived, I think he died in like the 60s maybe. But he's considered the father of modern lighting. He was a professor, and the name of or where he actually was a professor at, I can't remember, but he wrote a book in 1932 called A Method of Lighting the Stage. And it's gone through several editions and things like that. I don't claim to have read it, but I have just heard this and read through this method called the McCandless method. And essentially where the 45-degree angle comes into play is it's like 45 degrees up. So wherever your subject is, if you look up at a 45-degree angle, there's where your lights would be. And then you do a 45-degree angle onto the left and to the right. So you're essentially creating a 90-degree angle where your subject is. And so that's kind of the first part of it. And then the other part, or the second part of that, is one side would be cool and the other side would be warm. And kind of his theory and his idea on this was essentially to be able to sculpt the face and be able to essentially evoke or create a time of day. So you would have kind of the warm in the morning time or in the daytime, and then you could add that cool side to basically create no shadows. I'll give you an example of that right now. So we would have like a warm. This is a very warm look, but we would have a warm, and then we would couple that with a cool, and essentially you would get basically like a noontime. So when you add them both together, you kind of get that no shadow, noon, daytime, daylight color. And then as we kind of get into, oops, I was on the wrong one. There we go. So as we kind of get into kind of the nighttime, we would bring in more of that cool light to evoke kind of daytime passing. So that was that's kind of the McCandless method. So, but that's primarily where we get this idea of 45 degrees, and it's essentially the foundation and the basis for which we approach lighting, especially key lighting. And then there's another one which I'll add in here is basically like hair light. It's in my frame. I couldn't quite get it high enough so you can kind of see it. It looks like I have a halo. But essentially it's like hair light, key light, backlight. So when you add kind of all of them together, you sort of get a full kind of tool set. And that's sort of the thing of I try to reference it at all of these as tools in your toolkit. So there's certainly, if you worked with me for, I've been doing this a while, and there's certainly a lot of ways to approach lighting. And if ever I kind of get into like someone is explaining to me how they do it. I mean, that's certainly a way to do it, but it's not the way. And it's one of the things that we kind of need to keep in mind is there is, it just depends on what your situation is. So if you're shooting for camera, you're probably going to want that flat look with maybe a backlight to pull them out of the background a little bit. But you probably don't want those shadows to make it look dramatic. But if you're doing, maybe a more intimate song, like what we do is primarily house of, I mean, we all work for a church. So what we do is for those moments, those worship moments. So you may want something that, has kind of a cool feel to it. And then you may want to maybe just add a little bit of that warm fill light in. So it just depends on what you're doing. And I've got this side light here too. You may want to hit it with like something that's a little bit more dramatic. So it's all a matter of perspective. It's all a matter of what you wanting to accomplish when approaching front light. So yeah, that's kind of the brief history of the McCandless method. So we can kind of get into some examples here. I know I've kind of been pulling them in, but one of the things that I like to do, and it's like a question of, okay, when I'm approaching stage lighting, do I want a wash light? Do I want a Lico? Do I want a Fresnel? And even to take it a step further, what kind of wattages do I want and what color temperature I want those lights? And it all depends on like your throw. So my preference is if I can get away with it and I'm not throwing a far distance, I'm going to use a wash light. So I know at some of our campuses we use like the 2K Fresnels, Source 4 Leica or Source 4 Pars are a great light. And the reason for that is really to avoid some of like the harsh shadows that you can get from a Leica or from an ER or a ellipsoidal fixture. Sometimes you want that. But the other thing is blending. And that's something that it's always a challenge. So, and especially with the McCandless method, it can be pretty difficult to use all of those as a system to cover evenly a pretty wide area. So if you're looking at covering 40 to 50 feet, using the McCandless method can prove to be challenging, and it's resource intensive. You need 2 sources for each section, each pool of light. Technically 3 if you're adding in that backlight for each of those. So, but it can be done, and it just takes a lot of fine tuning, a lot of focusing, a lot of and especially if you're using gels for the warm and cool, just maintaining those. So what I prefer would be to use a source, whether it's a wash or a Lico, and I tend to just go straight on if I can. If I can't, a little bit of an angle is okay, but I tend to go straight on, and then I basically like to overlap the pools, the beam fields, about 40 to 50%. And so the reason for that is, if you can see behind me, you can kind of see there's a little bit of a fall off the farther. I mean, obviously these lights are focused right at me. So you can kind of see as we come closer, the intensity's a lot more, but then there's quite a bit of a fall off towards the edge of the beam of the beam field. So adding that overlap of, just depending on what lensing you're using and what kind of fixtures you're using, can kind of help even that out. So you can essentially, by shooting straight on, you can cover a wide area really quickly, and it's not as resource intensive because it's 1 source per area. So if you're covering, a 50-foot area, and by the time your beam field gets to the stage, it's 10 feet, and you add in, that 40 to 50%, you could probably get by with about 6 fixtures or instruments for if you're trying to use theater terms. Um, so you can probably get by with about half of what it would take by using or by kind of going straight on versus using the McCandless method. And then there's also, by using just going straight on, you do lose. So as you can kind of see, I do have quite a bit of shadows on the side of my face. So there's a lot of churches that are almost 180 degrees as far as seating goes. And so you have like just a super wide, audience to work with. So if this looks really great right here from this point of view, but if I'm looking from this direction, I'm going to be seeing quite a bit of dark, quite a bit of dark shadows. So that's where adding in, it doesn't need to cover that whole, you don't need basically one side light source for each position, but using a fill light or something like that covers that whole area, or maybe a couple, can work really well to sort of fill in, those, there we go. To sort of fill in those shadows that your congregation is going to be seeing, on the far left and right. So I lost my train of thought there, but the other thing too, that's with wash lights. If you're stuck with the last church I was at, the throw distance was pretty significant. So we were kind of stuck to using, I'm going to go back to this scene. We were not really stuck, but it was just more efficient for us to use a Lico. And with Licos, you have a hard edge beam, which creates a pretty hard shadow. And so the method that I kind of use to sort of combat that is I will line up all my Licos, and you need to make sure that you're essentially doing what's called a bench focus, especially if you're using conventional fixtures. LED, so if you're using like an Ovation or a Studio LED or something like that, you don't really have to do this. And by really you don't have to do this at all. But with a conventional fixture, you have to do what's called a bench focus. So if you take your light, you're going to notice a couple of bolts on the back of it. And what that's doing is, as you adjust those, it's moving that element around, that literal lamp source around inside of that ERS reflector. And it's essentially, if you look at the beam field of a conventional, you're going to see hot and cold spots. So what that's going to do is, as that element moves around, it's going to even those out. And so you want to make sure you spend some time. And if you already have your lights in the rig, all of our churches have a projector screen or something. Just point it at that and play with those knobs on the back, those screws on the back, and try to get that beam field as even as you can. And in theory, as you swap lamp, as the lamp blows and you swap them out, in theory it should hold, but you almost have to do it every single time just to fine tune it. And then, so once I do that and I get the focus, I will get the beam edge as crisp as I can get it. And I do that across. So if I've got 8 instruments or fixtures, what I do, I make sure they're all hard edge. And then I go through and I drop in like a Hamburg diffusion or something. That way I know that every source is diffused the same, it's focused the same, and I'm getting the most even beam field as I possibly can. Like I said, that works. That's for conventional fixtures also, or mainly LED fixtures. You don't really have to worry about that. So yeah. Do we have any? I don't have the chat up. Do we have any?
Yeah, I got you, Matt. So I had a question for you. What's your favorite color temperature?
I'm not a true 56K. I like to live in that like 45, like 43 to 45K range. 56 feels too blue to me as far as like live, like on skin tones. But 32 seems too warm, like I'm lit with a candle. So I like to live in that 4 to 4500 range.
So, yeah, so I noticed, Joe would just point this out. So I noticed we say warm and cool a lot. And in that, we're referring to color temperature. Can you show us an example of a cool color temperature?
Sure. So cool, and I'm gonna be a little aggressive on these just for the sake of let me turn this back off. So cool would be this. So it's cool. It's blue, and where we get that from is we lighting is based on Kelvin, and that comes from if you look at a flame. So your basic standard candle, Yankee candle at home, burning that apple cinnamon or whatever
Just
you
your
like.
basic standard Yankee
Just
candle.
your basic standard.
Hate that store.
So,
my gosh.
I'm a more of a Woodwick guy myself.
Okay, stop.
But that color that actually has a color temperature, and it's a low temperature flame. So you got to understand that the lower the temperature of essentially that flame, the redder it's going to be. And then the higher a color. So if you look on your, like, if you have a burner stove at home and you turn that on, it's like natural gas or propane or whatever, you'll notice it's a blue flame. That's because it's a higher temperature flame, which means it burns in a bluer color. So we use the term warm and cool, but in like actual physics, the cooler something is, actually the hotter it is. In our case, that is not completely true, but so this would be an example of cool. So you see it's blue. It just feels like, when you think about temperature, it feels colder. So blue, and then warm. I'm gonna do it on this side. So warm is I didn't put a meter on this, but this is probably about 28K. But warm is it's a lower on the spectrum as far as like it's on the redder side of the spectrum. So you've got, in the basically the visual spectrum of light, on the lower end side, getting into the infrared is red, and then the hotter something is, we're getting into the cooler side. So that's where that comes from. So you combine the two and you get something that looks a little bit like this. This is a little bit of an extreme example, but kind of get the cool on this side and then the warm on this side.
Yeah, I have a picture, just a scale of what this color temperature scale looks like. We're talking about Kelvin, and as we get lower in temperature, and again, like this is Kelvin is the temperature at which flame burns, or objects burn, and so the lower we are on the Kelvin scale, the warmer it is. And so like you get down to 1000 Kelvin, it's almost like red. But then more natural color temperatures are around this 3200. And so when we talk about light, a warm white, if you buy a warm white light bulb at Lowe's or whatever, that'll be closer to 3200 Kelvin. And if you buy a daylight, we'll refer to daylight, that's kind of like 5600, this range right around here. That's what color temperature it might be outside on a cloudy day. And this is super important with video, because your cameras have to know what color temperature your light source are. Because if they don't know, if your color temperature of your fixtures is 3200, but your cameras are set to 5600, right? Like your natural eyes will adjust to that. And so a 3200 Kelvin light source will eventually look white, like natural white to your eyes, but cameras don't. I mean, some of them have auto white balance, but static color temperature cameras, that will look orange. But if you change your color temperature in your camera to 3200 and your light sources are at 3200, then that will actually look white on camera. That's the whole idea of white balance, is telling your camera, hey, what color temperature is actually white right now? And then it kind of adjusts everything around that.
Yeah, and that's that's super important to bring up too, because as we're in the church world and have so primarily our cameras are pointed at the stage, but if you're wanting to capture any sort of crowd shots or anything like that, making sure your entire room is set to the same color temperature is super important, specifically for that reason, because um, anytime church is talking about, oh, well, we want to make the stage 56K, like more of a daylight color temperature, but the house is all tungsten. When they do those crowd shots, it's like, man, what happened?
Yeah.
What happened to the audience? They're all orange.
Tristan from the chat is asking what color temperature we use at Valentine.
It for sure varies. And correct me if I'm wrong, Andy, because we've essentially used we kind of very similar to the McCandless method. We have kind of a warmer, and then we have a cool. So the warmer is like our key light, and I think that's in like the 4-ish to 5 range. And then we have a cooler one that does sort of the fill, that it's doing that fill light, and that's in like the 56 6K range, something in there. It's not, I don't know if it's actually tied to like our actual presets. I think we have like a special preset that's buried in a layer. But it's one of those like we set it and then we just know that it's what it is. But I think our key light is in that 4 to 5 range, somewhere in there.
Yeah, sometimes we'll actually go a little bit more extreme, like you were doing earlier, for dramatic effect. I will say for the sermon, we do run more closer to what you were saying earlier with your preferred color temperature. Well, we will go kind of more in like this range, just south of like 5,000 Kelvin, more like 4,700 Kelvin. Reason being is that, pure daylight, and the thing is, like when you're working, what we do a lot of times is work with video, because we have LED screens on stage. We used to do projection on stage, and a lot of those sources, projection and stuff, are actually really cool. They're in this like 5600 range. So it actually, in order to put a white graphic on a projection or LED screen, your cameras need to be in this cooler color temperature to make that graphic look white on camera. But then if your person is lit with a source that's 3200 Kelvin, your cameras are seeing a white graphic on screen, but everybody on stage looks orange. So what we do is we kind of split the difference, because if we adjust all our lighting to 5600 Kelvin, then everybody on stage in real life, in person, looks just like blue and kind of sickly. Some people do. Some people commit all the way to pure daylight for front light, but it just looks a little bit cool in the live production environment. So we kind of settle a little bit lower in the middle to where 4,700 Kelvin is a little bit more natural, but we don't have to adjust our screens to be so warm that they look orange in person and unnatural. So it's just finding like that balance of compromise.
Yeah, and for sure, it's worth noting too, like anything that you have on your stage. So I know at Valentine we have LED sources, but even a projection surface like that's a source. So it's anything that is a source on your stage is worth taking into consideration as far as choosing color temperature and things like that, and making sure everything is basically jiving with each other. And kind of to talk about, like, we occasionally will go like extreme as far as like a super orange side light or things like that. It is important to make sure that, especially if you're using cameras, that you're at least lighting the face with something that the camera is like. So hitting with like a front light, even though it might be your fill light, but it gives just enough for the cameras to see the face and not look like blue and orange and like super moody. There's certainly a time and a place for that. But like specifically at Valentine, we have 6 Lecos on either side to do like kind of that sort of side, like super blue, super orange, and just to create and sculpt the face and the stage and the mood, while also giving that key light that makes the cameras happy. Because when the cameras aren't happy, it's people we're for sure made aware of that.
Which is actually a good segue into another question. How do you choose between conventional sources or LED sources?
Budget.
Yeah.
So budget plays a huge role in that.
But you can get a lot of LED sources for real cheap. Actually, probably cheaper at this point.
Yeah, for sure. It really comes down to, I mean, it's one of those things. I guess the line is super blurred this day and age because even 2-3 years ago, it was a brightness factor. It was a dim curve factor. It was a color rendering factor. And you could get all of those for a bukus of money. But now, and you've got the Ovation line, the ETC, the Studio LED line, Elation has theirs. I mean, just about everybody has some sort of LED Leco. And so for me, it comes, I look for brightness. Does it compare to, because if you look on, you get an ETC source 4, that's sort of my standard for a conventional. And if you can get something that renders that color, is that brightness, that gives you all of the things that you want as far as color temperature goes, even beam field. And the thing with the LEDs is the beam field is super even. You don't need to do any sort of bench focusing or anything like that. I'm kind of looking at it from a feature set and budget. I can get a really nice LED source that gives me all my tungsten, gives me all my color temperature, and looks great on camera. But I can also, if I use that in a system, I also have full color. So I could do, basically light everyone in like a deep blue or something, and then just highlight that person. And you also have cost of ownership. You're not buying, you're not stocking lamps. If you're using gels, you're not having to regel all the time. And then there certainly is an energy cost. I think that is a little bit, you kind of got to do your math on that, because sometimes doesn't really give you too much of a savings there. But it's just a matter of feature set. I think we're in a day and age where that line is blurred over a conventional or, LED. It's like, how often do you want to service it? You don't want to you can't get to it very often. I know, like Gaston, for instance, we basically donated all of the bodies, the Source 4 bodies, but they actually replaced the engine with the forward engine. Because they can't get to them very often, they have to bring a lift in and everything like that. So they focus them, and then they don't have to really worry about lamp replacement. The other thing would be, you have to think about data distribution. So with a conventional, you only have to worry about power, dim up, dim down. That's it. With a LED source, you have to think about DMX. So you have to think about, one, if your distribution is primarily dimming, you have to think about, well, now I need to actually get this source power, not just dim power. And there's modules and things that you can do to probably salvage that. But you have to think about, I need to actually have like a non-dim power source, as well as I need to have DMX distribution. So the forward, for example, is it's only Cat 5 in and out. So there's not actually any 5-pin cables on there, but you have to, that could be a solution. Cat 5 is pretty cheap, but you have to think about some sort of a node. If you're kind of an older church that is thinking about moving to LEDs, these are just things you got to think about is, do I have a controller that has enough universes? Do I have all the cabling that goes with it? Especially if you're doing 5-pin, just those are sort of the logistics and the details to think about. Some people, it's oh yeah, I have all that. It's just a hot swap thing. I've got all the distribution in place. But for others, you know, you got to think about that. That's an additional cost on top of the cost of the actual fixture.
Yeah, just got to hot swap it.
Hot swap.
I was going to mention one other factor to consider, and it's becoming less and less of the conversation because LED fixtures are getting better and better. But the reason everybody didn't just jump on LED when it first came out was this topic of CRI. CRI stands for Color Rendering Index. I'm trying to find some charts, but there's some like different thoughts on how this all works. But what it comes down to is like different light sources can kind of render colors better than others. So things like incandescent lamps or sources like that are going to be higher CRI, and CRI is like 0 to 100. So a lot of times we'll look at a fixture and see a CRI of like 95, and that's going to mean that that's going to render really good color, especially for camera. The human eye can forgive a lot of things, but like fluorescent light, if you've ever grabbed a video camera and wondered why the lights in your office building look green. Well, it's because fluorescent light has these big green spikes that really aren't visible to the human eye, but to camera, they're a lot more sensitive to this kind of color spikes. And that's kind of what LED does too, is there's spikes in this green and blue range. And so whenever somebody grabs an LED fixture off the shelf in Guitar Center and they put it up in their church and they wonder why all of a sudden all their people look like they're green and sick. And, you know, that didn't look that way in Guitar Center. Well, it's because your cameras are picking up those green spikes more than your human eye is. And so you buy LED fixtures, you really want to consider CRI, or there's a kind of more different metrics that help measure this idea of like how accurate is the color when it's seen on camera. But CRI is definitely one of the more popular ones.
For
so
sure.
When you see a fixture that has a CRI, it's like super cheap, but it has a CRI of 75, you want to probably avoid that one especially if you're doing stuff for a camera. But a higher CRI fixture might be just fine. And as long as you consider all those other factors you mentioned, might be a good option for you.
For sure. Yeah. And a lot of people, I think ETC kind of jumped on it first, but a lot of people are on that Lime train, adding that, like, so you'll see like RGB AW, but you'll see like RGB AWL, and so that's for that Lime. So like when you like the color run, the CRI kind of chart you're talking about,
Yep.
You'll see like RGB have pretty significant spikes, but there's a sliver in that Lime section that is so anyway. So I guess if you're looking at LEDs, try to get on that lime.
Get on that lime. Just add a little bit of lime.
The other thing to consider too is just making sure. So LEDs they flicker, so that's how they emit a pulse at some obnoxious rate that we can't see.
Right.
But lower LEDs. So I know there's a lot of like, go on Amazon or Alibaba. There's a lot of cheap, Chinese LEDs out there, LED fixtures, and some of them don't have, any sort of rating on being able to adjust that. And a lot of cameras have that adjustment. Again, it's just one of those things to consider when, switching over to LED. There's just a lot more factors that go into it when versus a conventional fixture.
So it's like, what is the refresh rate of the fixture?
Right.
If you have a fixture with a really slow refresh rate, then you're going to end up, because cameras also kind of work in that idea of like a refresh rate. It used to be a mechanical shutter that would open and close physically 30, 24 times a second. Nowadays it's a lot more digital, but they can replicate some cameras. They still have that refresh rate of 60 hertz or whatever it is. And so if there's a misalignment in the refresh rate of your LED lights and your cameras, that's what creates those like rolling lines and those flickers, because your eye has persistence of vision, and so it can't tell that those LEDs are refreshing, but cameras don't have that. And so it'll appear as like running lines, scrolling lines, or flickers on
you kind of see it, I think, with the green, like on the back, like my back ones, you can kind of see it a little bit. These are just some cheap DJ lights, but yeah. Anyway.
And just one thing to add to that, Jeremy Riley was asking just some tips for LED fixtures. One thing I left out when we talked about CRI and kind of like people looking green on camera, there are still some fixtures that have great output and great brightness, but the CRI isn't quite there. It's closer to like 80%. And so with a lot of fixtures nowadays, they include what we call a high CRI filter, or basically some people will call it a minus green. But when you're working with not just LED, but even like arc lamp sources or anything that has a lower CRI, a lot of times you can put a filter in front of it that basically the output of the light might look a little bit more pink, but really what it does is it takes some of that green out and kind of evens out some of that green spike and makes it look a lot more natural on camera. But it might cut the output a little bit, the brightness a little bit, but you can put a half minus green or a high CRI filter, depending on who's doing the marketing, and kind of help with that color rendering. So we have a half minus green in our fixtures at Valentine as well, because we're using arc lamp sources, and that helps make it a little bit more natural on camera. The last question, a few people were asking, what if you have, like, how can you avoid spill? Because a lot of times you might not have the stage depth to do a front light the way you want it without it spilling on the backdrop. So how can you, like, what are some methods you can do to avoid some spill on the backdrop or on your back wall, on the drape, whatever?
Yeah, that's always it's just the constant struggle of avoiding that, of only getting light where you want it. And you kind of got to break the rules a little bit of we talked about the McCandless method. And if you're able to get away with it, just go at a little bit of a steeper angle. Not crazy. So, try to find, if you're able to get into your space, and try to find that happy medium. I was at a church up in Raleigh, Focus Church, and I was kind of redoing their key light, and I was trying to get a better angle specifically for this reason, because there's all kinds of spillage on the front, and they had some taller pastors, so I couldn't quite get it where I wanted it. So maybe moving versus the fixture hanging down, mounting it on top. I mean, rigging needs to be important with that, because, we were fighting the laws of gravity there a little bit, but being able to kind of increase that angle to maybe 55 degrees at most, I would say. And then potentially adding in maybe some footlight to sort of fill in some of those raccoon eyes that you might get. So steepening the angle is one. Another thing that you can do is maybe, if you have basically some space on your stage that you can allow spillover, so maybe onto the sides or whatever, depending on the size of your stage, and moving your fixtures, your key light over and coming at more of an angle, and then still using that front key light or that front light, but instead of as a key, using it more as a fill to kind of just fill in a little bit of that, because coming at a wider angle from the side, kind of from the front, looks weird, for lack of a better term. So adding in a little bit of, instead of using your front light as the key light, which can spill all over your backdrop and your set and everything, you can kind of lower that intensity, and then so those are a couple of options: steepening the angle, maybe utilizing foot lighting, and coming at it from maybe a steep or a wider angle versus a steeper angle. Those are just a couple of options. The other thing to note too, as we're talking about, if we're using conventionals and changing intensities, understand that change in intensity shifts the color temperature. Mm-hmm. So and it may not be as drastic as whatever, but it is worth noting. So as I'm kind of throwing these things out, I was thinking about, we just lower the color temperature or lower the intensity. Well, that also does shift the color temperature. So you potentially, depending on your camera setup and everything like that, you might need to cool it down at those lower dim, those lower intensities to cool it down a little bit, because it might be too orange depending on what you're doing. But anyway.
Jose was asking, do you consider audience lighting a responsibility of the AVL team? I guess house lighting. If you were to design a new main campus, would you adjust the stage lighting or the rest of the room?
Both, and they need to work together. And it also depends on what you're doing. If
for sure.
if you are only focused on the stage, the other thing is too, making sure, because there's other factors that go into it. Doing a wide shot of a room, and it might be a down weekend, and you've got all kinds of empty seats, isn't necessarily the greatest thing to do. So you may want to dim the house or make the house a little bit darker. So I think they're very much one and the same. And being able to utilize. So you're talking about putting it in, like designing a new campus and a new building. And I wasn't a huge fan of the RG. I just didn't quite get it, of the RGBW house light stuff, because I'm like, no, I just want a good color temperature that I can maybe adjust more zones or each individual fixture. But I'm not going to do like a rainbow. Now that we have, I've used it, I'm like, oh yeah, I'll do this and make it for certain events, not all the time.
Well,
I'm not doing like an invit.
One thing that I've found with like the RGBW house lights, because that's been a big thing nowadays, is like people putting RGBW house lights into new buildings. And I mean, the thing is, like, house lights is where you can spend almost all of your budget. That's another thing with new buildings. You can spend a ton of money on house lights because it's just sheer quantity. But if you can do RGBW house lights, the reason I like it, and you can easily overuse, and I've seen people overuse it all the time. The reason that I like it is it allows us to do, because like for worship, in order to make it a little moodier, we just bring the house lights down, and that was kind of the answer. But now all of a sudden we've got into video, and it's more important to see the crowd in when we're taking camera shots to keep everybody engaged. But we still don't want it to feel like the house lights are on in the room, so we're able to use like kind of darker colors, but at higher brightnesses, so that in the room it's kind of the illusion that it's darker. But on camera, there's a lot more brightness. And we played with like angle and stuff too. We put some lights in the back of the room, so maybe the lights aren't overhead in the house, but they're kind of coming from the back of the room. So when you look around, you don't necessarily see people's faces, but you can still see silhouettes of people in the room. And then there are some spill that allows you cameras and stuff to see people's faces and reactions and emotion and stuff.
Super vibey.
Yeah, super vibey. But I think that's an important factor to consider is what are you doing? Are you doing this for video? And then, you might need a couple different angles, just like you need a couple different angles for worship, depending on what you're doing and what kind of mood you're trying to create. You might need to do that for your audience. It might not be as simple as turning the house lights on and off that we found. You might need to have house lights at one angle for this part of the experience, and house lights at another angle for another part of the experience.
Yeah. I look at, house, like any light that is in that space, it can affect the worship experience. So you need control over it. You need to think about it. You need to consider it. And it essentially needs to be designed. And so I remember like when we launched Orlando, tying into their house lights, and I built a layout of where all their house lights were, and I adjusted everything to kind of fit more of what the feel was coming into the room. And so I didn't just turn everything on. If you've ever been to one of our campuses, we use pipe and drape pretty heavily. So I didn't want the outside to be lit, where like outside the pipe and drape. So I tried to bring those down. I also didn't, want the aisles lit or each area like lit super bright. So I kind of, it's all things that need to be considered. So as far as, considering one or the other, you need to consider both of them because they're the same. As far as, one's lighting the stage, one's lighting the house, but as we've noticed, the world can change in a minute, and you're now basically shooting you have to have a studio So having that flexibility it's super important to think about both of them as a collective unit.
Devron says he appreciates y'all doing that for him in Orlando. So Stephen was asking, because at Lake Norman, he says, and I think this would be good to just bring it back to what you were setting up at the beginning, but Stephen was asking, because at Lake Norman right now, they have Lecos on opposite extremes of the catwalk kind of pointing in. He was saying, should they adjust that so they're straight on?
Well, specifically with Lake Norman and a lot of our we use yeah, I guess you're right. I was thinking about like the 2Ks. I'm like, well, we're using the 2Ks, but for worship, we're not really using the 2Ks. It's a little bit of a preferential thing. And if you have the resources, and I know Lake Norman does, most of our campuses do, to do that 2-point lighting, I would say roll with that, because the reason why I do straight on is you can kind of still accomplish the same thing, but with less fixtures. But if you have the fixtures to do a 2-point lighting, because doing a side key light with a fill light is super cool. And even dipping in, I know we're still on conventionals up at Lake Norman, but maybe having a conversation and getting some gels on one side and using kind of still have my key light sources coming from not necessarily a steep angle, but an angle nonetheless, so you can kind of get that fill light in there. It's totally worth it. I think if you have it, use it.
Yeah, for sure. If you have it, use it.
Yep.
And I think we'll call it. It's 1:00. Well, thank you all, guys. Anybody from the rest of the team want to add anything about front light, lighting design theory, key light, color temperatures, CRI, LED? What is everyone using as their key light right now?
The sun. Good old-fashioned sun.
Yeah, I have a window. Anything can be a key light.
Yeah.
The sun can be a key light, and then you can have a reflector as a fill light. It can be anything. Use what you got. If you got it, use it.
So this is a funny story. When I was like back in Illinois, there's an integrator who was working with the church. I'll make it quick. And is a new building, and they wanted to put this basically right behind the stage on the upstage, this giant window. And I think it faced east. And they were like, they asked the integrator, they said, oh, well, so if we're facing it this way, like how much of the sun is it going to let in? And he goes, all of it. It's going to let all of it in. So I think they ended up spending a bunch of money and covering it up anyway. But anyway, that's just a funny story about windows and sanctuaries.
Wow. Oh, man.
Anyway.
Well,
cool.
Great Tech Tuesday, everybody. Thank you all for joining us. Joe, you want to talk about what we're doing next weekend? Next Tuesday, rather?
Yes, next weekend we are going to dive into the world of signal flow, which you can instantly hear and be like, I know how to plug things in, but it's going to be much less just about teaching you how to plug things in and more giving you a good process for training volunteers and teaching people who are newer on your team to really think through how something gets from source to destination and what happens in between, both through cable to gear and then also the internal parts of everything. So it's going to be a really great one to tune in. All of us are going to contribute to some different things. And so definitely excited. Looking forward to it.
Yeah. I was thinking this might even become a 2-parter. Who knows? Might have to split it up into 2 weeks. But yeah, we'll see. I'm excited. Thank you all for joining us for Tech Tuesday once again. We will see you next Tuesday at noon. Bye, everybody.
See ya.